Welcome to the third video for the Minor Mastering Blockchain. I am Sam, and in this video I'm gonna explain more about hash functions, hash pointers and the Merkle tree. So I'll begin by explaining what hashing is. So hashing is the process of converting any input of any length into a fixed size string of text using a so-called hash function. This way I can convert data into an array of numbers and letters. So I'm gonna show you a diagram I've made. I've drawn something which is to illustrate how a hash function works. So this is the data which is used as input. This is the hash function. I drawn a black box because you have different hash functions which will convert on a different basis, but we can consider this one as a black box for now. So the data goes into the hash function and produces a hash, which is an array of numbers and letters. So what are hash pointers? Hash pointers are I've drawn the example here above, but a hash pointer points to where the hash is from the hash, and where the data from the hash is stored. So this will be the data. It's been going through this hash function, and you got a hash, and it points to the data which is used in the hash. So what's useful about hash pointers? Now we can use hash pointers to ask information back, and we can use them to verify that things haven't changed. So the value of the data hasn't changed at all. We can see that if it has changed, it would give out a different hash, which is an array of numbers and strings. So to further illustrate what we can do with hash pointers is we can use it in all kinds of data structures. We can build data structures around it, and I have drawn this one. This is the blockchain data structure, and I'm gonna walk through it and how it works with data points. So this is the hash. The hash consists out of the combination for this data and the previous hash. And to illustrate where the previous hash is coming from, we've pointed with the hash pointer to this hash, which is also a combination of the previous hash of the previous block and this data. So now we can see that the hash of this block is the combination of data and the previous block information, and points to where it is. And this way we can make a data structure which is similar to a blockchain. This is a tamper-proof system, which means that if we change or alter some data here, that will mean that this hash will be different, which will mean that this hash will be different, which would mean that if you combine this, that everything will be different when you start hashing this in this so-called hash functions. So that is why the blockchain data structure is called tamper-proof, because you can see that if you can verify if the data and the value of the data has changed or not. So next I'm going to explain what a Merkle tree is. A Merkle tree is a binary tree building with hash pointers. And I've also drawn a simple version of this. I've started with A, B, C, D. In this case, you could say that these are the transactions in, for example, Bitcoin. The way it works is this is a hash of transaction A. This is the hash of transaction B, the hash of transaction C, and the hash of transaction D. This is actually there has to be the transaction is underneath this and is hashed into A. That's the way you should see it. Then when you hash A and B and you combine them together and hash them together, you get hash AB. The same is also applicable for this one. When you hash C and D together, you get CD hash, and then you combine those together and then you hash it. And that's the way the Merkle tree works. This hash is called the Merkle root, and this is the one we use in the blockchain and is put on the block. So why is this useful? Why would you use this Merkle tree structure? Well, it's really useful because if we would change a single bit in this transaction, for example, I've sent someone 10 Bitcoin, which is transaction A, and he says no, I only received 5. We can check this because if I was lying, this would be not 10 but something different. It will give a certain hash. And if we combine those hashes together here, we get this one. But if this one is different from what I said, it means that the hash should be different here as well, because you combine those two and you get a completely different hash if you change the input. So that way you can really see where something has been altered. And the best thing is, if you want to check this one, in the Merkle tree system, you can ignore this root. You just follow the transaction based on the Merkle tree itself. The Merkle tree, you can also use it for different kind of applications. It could also be used to hash some files, and it's a way of structuring your data so you don't have to, so you can quickly verify it and be sure that it's tamper-proof. That was the lesson in hash functions, hash pointers, and the Merkle tree. I hope you liked it.